So far we covered various aspects of graphics LCD operation. Now let us analyze few ways of connecting it to PIC24 devices. The first variant is display with built-in LCD controller. These type of LCD modules have some kind of parallel interface for host MCU connection. They may have Intel 80 or Motorola 68K in 8 or 16-bit flavor. Majority of the 3-inch and smaller size displays are of this type. This type of display tends to provide most compact form factor and are widely used in handheld applications. These displays use a single chip solution as LCD controller to interface with glass. The LCD controller has a high voltage gate driver, remaining digital logic, and usually one page of image buffer built into it. Many LCD module manufacturers use bump type package to get low cost and smaller size. If you are planning to use any particular LCD module with this kind of interface, then please look into the LCD module dataset for LCD controller part number. Lots of vendors like Samsung, Solomon Systech, Hightech, Renesas, Elitech, LG, etc. manufacture LCD controller chip. The graphics library is tied with this LCD controller. If you find LCD module from two different vendors using same LCD controller chip, then you should be able to use both displays without any change in firmware. While migrating from one LCD module to another, if LCD controller changes, then you need to change the LCD driver in graphics library to use it. All color displays require some kind of backlight for operation. Smaller displays use LED backlight, which simplifies the backlight power supply. Most of the time they use more than one LED. If they use multiple LED in series, then you may need higher voltage for backlight. If multiple LEDs are connected in parallel, then you will need a lower voltage for backlight. Almost all LCD controller operates at 3 or 3.3 volt. If you have only one supply available, then parallel LED configuration is preferred, as backlight may be able to run on same 3 volt supply. For series LED configuration, you will need higher voltage. The bigger displays may use different kind of backlight like CCFL. This may require inverter to generate high voltage. The PIC24 devices have Parallel Master Port Module, the acronym is PMP, which is a highly configurable parallel interface module. It can be configured for Intel 80 or Motorola 68K interface in 8 or 16-bit flavor. Microchip also provides free graphics library with all Microsoft Windows kind objects to simplify design. If you are planning to use touchscreen, then it is very easy to interface resistive touchscreen with PIC. This slide shows timing diagram for Motorola 68K interface and Intel 80 interface. The Intel 80 interface has separate read and write signals, while Motorola 68K has one pin for read and write function and another control signal called enable. They both have support for 8 or 16-bit data bus and chip select signal. If you are planning to use LCD display which has RGB interface, then they can't be interfaced with PIC directly. Usually many displays of 3.5 inch and bigger has this kind of interface. In this case, the high voltage gate driver is built into the display, and display has data bus for R, G and B signals. The 16-bit color display may have 5 lines for R, 5 lines for B and 6 data lines for G. They also have few additional signals like clock, horizontal sync and vertical sync. This interface is fully digital interface and usually accepts TTL level. In this situation, we'll need graphics controller chip between PIC24 and LCD module. The graphics controller chip has digital voltage creation logic, image buffer, and sometimes graphics accelerator. It will have a CPU interface for host connection and RGB output to drive LCD module. Usually graphics controller chip is highly configurable. It can drive variety of LCD displays like STN, TFT, monochrome, etc. They have configurable interface to support variety of timing needs. The SSD1906 from Solomon Systech is example of one such implementation. You can find graphics controller chip from few other vendors like Epson. It is also possible to create graphics controller using FPGA or CPLD. If FPGA or CPLD is used, then most likely it will use dedicated RAM chip for image buffer. Some FPGA vendors provide IP of graphics controller to their customers free or at very low cost. I will not try to explain RGB waveforms in detail here. The only reason to have this slide is to help you identify RGB interface. If you see above type timing diagram in your LCD dataset, then it is RGB interface. In this case, you will need external graphics controller explained in previous slide for interface. In most cases, you will find equivalent pin name on graphics controller, making it easy to make connections. This ends our webinar.